So, what would actually happen if two gigantic galaxies, each packed with billions of stars, just started pulling each other apart? I mean, it sounds exactly like the setup for a crazy science fiction disaster movie, right? But it actually represents one of the most spectacular transformative events in the entire universe. Welcome to this explainer, where we're going to dive right into the mind-bending reality of galactic collisions.
Now, if you hear the phrase galaxy collision, you'd probably expect this sudden, fiery explosion of cosmic proportions, just a completely chaotic smash-up where planets and stars are utterly destroyed. But the truth is actually far more beautiful and a lot more surprising. Galaxies absolutely can and do collide and merge, but because the distances between individual stars are just so incredibly vast, direct star-to-star collisions are almost impossible. Most stars will probably never physically hit each other. They'll literally just glide safely right past one another.
So instead of this violent, instantaneous smash-up, a galaxy merger is really more like a majestic, billion-year-long celestial ballet. It's a process driven entirely by the invisible, absolutely relentless force of gravity. And because these structures are so gargantuan, galactic collisions take place at an absolute snail's pace on human timescales. We are talking about a slow, methodical reorganization of matter that shapes the very evolution of our universe.
All right, let's get into part one, the cosmic smash-up, where we'll be deconstructing a galaxy merger step by step.
To really wrap our heads around this, we need to break down the actual mechanics. Based on the Incredible Goals survey, we can clearly see the incredibly slow, multi-stage process of a merger that literally takes hundreds of millions of years. It all kicks off with these first gentle tugs of gravity teasing out dust and gas as the two galaxies approach each other. Then, over hundreds of millions of years, their gravitational fields deeply interact. They pull material outward, heavily distort their shapes, and fundamentally alter the stellar orbits of both galaxies, until they finally coalesce into a single, twisted structure.
The thing you really have to look out for during this process are the tidal tails. As the outer reaches of the merging galaxies begin to intermingle, gravity rips material into these incredibly long, spectacular streamers. They are the absolute visual signature of a galactic interaction. And what's super fascinating is that these ghostly tails can persist long after the main action of the collision is over, basically serving as a lasting visual record of the cosmic encounter.
Moving right along to part two, forging new stars, or as I like to call it, the cosmic star factory. Far from just destroying things, these gargantuan encounters actually act as colossal engines for birthing brand new stars. Remember how we said individual stars rarely collide? Well, the vast interstellar clouds of gas and dust absolutely do. As gravity forces the galaxies together, this gas gets violently accelerated and buffeted from every direction. This massive compression sends huge shock waves rippling through the clouds, causing them to collapse and ignite this blazing rash of new star formation. As the dust clouds build up, they heat up, they glow intensely in the infrared, and they churn out these brilliant blue knots of young stars. It's a total game changer for the galaxy. To anchor all this abstract physics in reality, we just need to look at the Antennae Galaxies. Located a staggering 65 million light-years away from us, this celestial firestorm is literally the blazing wreckage of a fateful confrontation that started hundreds of millions of years ago. Here, two once-separate spiral galaxies got entirely entangled in a cosmic dance, and their collision completely compressed huge clouds of gas, igniting billions of new stars within these beautiful pinkish star-forming nebulae.
Now, deep within the heart of those Antennae Galaxies, the Hubble Space Telescope actually found over 1,000 young superstar clusters. Astronomers believe the largest of these are going to survive the whole merger to become giant globular clusters. And this was a huge deal. For the longest time, we thought globular clusters were mostly ancient relics left over from the universe's earliest days. But this observation basically proved that they are also actively being born right now as a direct result of modern galactic collisions. To truly grasp the extreme physical scale of what's happening out there, you have to realize just how intensely dense these young clusters are. They are typically only about 60 light-years in diameter. To put that into perspective from our viewpoint here on Earth, that would look to us like the size of a dime seen from 60 miles away. Literally millions of stars packed into that incredibly tight spherical formation. If you want another breathtaking example of this star-birthing phenomenon, check out the elliptical galaxy merger known as SDS J1531 plus 3414. Here, astronomers discovered this unbelievable 100,000 light-year-long chain of young stellar superclusters just winding around the merging nuclei. They describe this massive, knotted rope of gaseous filaments and bright new stars as looking exactly like beads on a string.
And honestly, this brilliantly illustrates a really profound truth about our universe. The exact same fundamental physics that causes rain to fall in discrete, evenly spaced droplets right here on Earth, which happens because of surface tension, operates on a massive cosmic scale. Out in deep space, gravity just takes over the role of surface tension, causing the gas to knot up into equally spaced clusters along a 100,000 light-year chain. It just goes to show you, the laws of physics are truly scale invariant.
Okay, part 3, twisted outcomes. Let's talk about reconstructing the galaxy.
So what does the final twisted outcome of these colossal interactions actually look like when all the dust settles? Well, for decades, astronomers theorized that galaxy shapes weren't just random. They hypothesized that when flat, disc-shaped spiral galaxies collide and merge, the chaotic gravitational forces entirely disrupt those delicate structures. The theory proposed that these mergers ultimately redistribute all the stars into a single giant, diffuse and spherical system, what we call an elliptical galaxy.
And the absolute perfect proof of this structural transformation is the Atoms for Peace galaxy, or NGC 7252. It perfectly represents a billion-year-old merger between two disc-shaped galaxies that has now settled into an elliptical shape. It actually got its nickname Atoms for Peace because its bizarre loop-like tidal structures resemble a textbook schematic diagram of electrons orbiting an atomic nucleus, which is unambiguous evidence of the massive gravitational tidal forces it had to endure.
But the real surprise was hiding right inside the core of NGC 7252. Hubble discovered this tiny, backward-rotating pinwheel of gas and stars. It looks exactly like the swirling pattern you get when you just mix cream into a cup of coffee. This is actually where the supermassive black holes from both original galaxies eventually migrate, driving gas inward and potentially triggering intense new activity right at the galactic nucleus. And get this, with enough leftover gas rotating backwards, this core has the fuel to create 8 billion new stars just like our Sun.
Which brings us to part 4, our galaxy's future, the ultimate encounter.
Why all of this matters so deeply to us is because it basically offers a direct preview of our own cosmic destiny. Current computer simulations predict that our very own Milky Way galaxy will likely not stay in its nice, isolated spiral form forever. While it's not absolutely guaranteed, simulations show we are on a potential collision course with our massive neighbor, the Andromeda Galaxy, in approximately 4 billion years.
Astronomers are essentially acting as cosmic detectives here, studying nearby collisions like the space triangle and the mice to simulate exactly how our own galaxy will evolve. And hey, if you're worried about Earth, don't be. The distances between stars are just so vast that our solar system is extremely unlikely to suffer any kind of direct collision. Our Sun would most likely just get tossed into a brand new orbit around the new galactic center.
So the next time you step outside and look up at the night sky, remember that it is not just a static picture. It is a deeply dynamic, constantly changing canvas, a gradual waltz choreographed by gravity. When our galaxy potentially dances with Andromeda billions of years from now, we have to wonder, what brilliant new structures and glowing star clusters will be left behind as long-lasting witnesses to that ultimate celestial creation? Thank you for watching this explainer. Keep looking up.